number 1, network theory, charging and discharging characteristics of RC and RL circuit using multisim software. In this we'll study charging and discharging characteristics of RC and RL. Let's see the circuit diagram here. Now let's understand the circuit diagram. In here it has a pulse voltage of 0 volt to 5 volt and its time from 50 milliseconds to 100 milliseconds. It has a resistance of 1 kilo ohm and a capacitor of 10 microfarad and a voltage probe is there. It can be changed alternatively from voltage probe to current probe. Let's see the expected graph. In case of voltage probe, the capacitor charges with the time and then discharges in case of voltage, but in case of current, the capacitor discharges, then it has a reverse current here. But in case of RL, the same thing for inductor of 1 millihertz for 1 millihenry and 1 kilo ohms from 0 volt to 5 volt and 1 US to 10 US, it behaves oppositely. Here for voltage versus time, it discharges, then it has the negative, this one. Then for current versus time graph, it has charging and discharging. It's opposite of resistor. Okay, let's see the software part. A theoretical time constant for RC is 1 millisecond. It will be 0.1. Transient will be taken. RL circuit, it will be 1 microsecond. Then it will be 0.00001, means 0. There will be 4 zeros and a 1. The tabular column will be like this. For RC circuit, it has voltage and currents, charging, discharging, and the time, and a same tabular column for RL circuits. Software part. First we'll see how to use the software. With that we'll do the experiment also. First we'll go to place, then we select the components. Now here we need the source, so we'll click on source. Under source we have signal voltage. In signal voltage we get pulse voltage. Click on OK. We'll get a pulse voltage. Now double click on that to set the appropriate values. Now in this, initial value is 0. It starts from 0 and it ends at 5 volt. Then here the pulse width, make it as 50 and make this as 100. Then don't forget to select the magnitude. The AC analysis magnitude, since it is 0 to 5, it's 5. Click on OK. Now we are performing for RC, right? Then select on for resistor. First we'll go to basic. Under basic we go to resistor, then click OK. We have 1K resistor. Then go to capacitor, click on OK. You get a capacitor here. Then for rotating, click CTRL R, it will get rotated. We need 10 microfarad. So double click on it, and now set for appropriate values, 10U. Okay. Now connect these two, then capacitor and resistor, then the capacitor with the source. At last come here to source. Under source, power sources, we have ground. Click on OK and place the ground here. Now go to interactive. Before going to interactive, you need to select the probes. This is voltage probe and its current probe. First let's check for voltage probe. Under voltage probe, the capacitor charging and discharging can be seen. Then go for interactive. In interactive, we'll go for transient. Now in transient, we'll set start time as 0 and end time as 0.1. Click on save, then click on run. You'll get a graph like this, its charging part and its discharging part. Now I will tell how to take the values for the tabular column. Okay, to take values for the tabular column, see, for reference you can check the tabular column. I'll put the tabular column at the beginning, a screenshot I will place it. For that, for 0, let's check 0M, setting the X value, click on OK. It has set on 0 value. Here see the Y value, it's 0. For 0 it's 0. Then here set X value as 10M. For 10M, the Y value is 3.1613. Note down this value under T is equals to 1T. Next, this is for voltage, under voltage charging. Then set X value as 20M. Click on OK. Then write the value of 4.3258 as Y1. Like this, when you do till 5, you get the charging. Same if you do after, then you'll get discharging. See here, we'll set X value as 50M. From here the discharging starts. For 50M, it has 4.9668. Now the capacitor starts to discharging, setting the X value to 60M. From 60 it will start discharging. Write OK, means click OK. See, 1.8307 from here it has started discharging here. Let's check at last. At last we got 100M. We'll check. For 100M we have 32.9402M. For reference, I will place all the values of RC and RL, both charging, discharging of voltage and current values. Now let's see for current. Take the current probe, put it here. Now start on run. Transient will be same. So for this, the obtained graph is same as the old graph. Here also same. First, to get cursor, go to cursor, show cursor, then you'll get the cursors. Take any one of the cursor, set X value 10M. For 10M, it has its value 1.8387. Like that, check for all the values and write the values for charging and discharging. You can do like this and get all the values. I will put the screenshot of all the values in a tabular column for reference. So with this we complete RC. For RL, we need to draw another circuit. We'll replace it here only. For that, we'll change the values. 5U to 10U. Okay. RL. For L, we will replace the component with an inductor. Its value should be 1 microfarad. So we have 1 micro Henry. Okay. First we'll go with current only, because the current only we can see the charging and discharging of inductor. So you need to keep in mind regarding the transient. Here the transient value will change from 0 to 0.0000401. Save, then run. You get the of charging and discharging. And same way, if we do for the voltage probe, then run. Now you can see the reverse of that. Same way, if you do for setting X value, then you'll get the same values. Go to cursor, show cursor, select any one of the probe, right click, select X value. Here you should type 1U, 2U, like that, for obtaining charging and discharging value of voltage. No, for voltage versus time in here. So you will get the values. Thank you.